Class. I welcome you once again to our today's class. Just like in our previous class, we learned how to derive the formula for calculating the length of an arc, and we also went further to apply that formula to solve some calculations. And from there, we proceeded to how to determine the formula for calculating the perimeter of a sector, and we also went further to also solve some problems using that very well formula. So today we are going to learn how to determine the formula for perimeter of a segment. Now, when you hear the word segment, what comes to your mind? Now, let's take a sketch here. Looking at this sketch, this is a what? A circle, okay? A circle having a center like this. If a line is drawn such that it does not pass through the center of the circle, okay, like this line that is drawn divides this circle into two unequal parts, okay? Meaning that this very portion here, this part, is called a what? A segment. Okay? Now, you might be wondering, how do we find the perimeter of this very what? Segment. It is very simple, not difficult. Okay? To find the perimeter of this segment, simply have perimeter of segment to be equal to what? This, what you are seeing here is called a chord. Okay? Any line that cuts a circle into two unequal parts, okay? That line is known as a what? A chord. Provided that it does not pass to the center of the what? Circle. If it has passed to the center, it would have become the what? A diameter. So we are going to have length of what? Chord. Then what are we going to add again? From here to here, this, let's say here is what? A, and here is what? B. So the length of A to what? B is known as the length of the chord, okay? Then let's say here is X now. From A, X, B is what? An arc, okay? So I'm going to have plus what? Length of what? An arc, okay? When you add this length of the chord plus length of an arc together, that will give us the perimeter of this very word segment. This is how the segment looks like, okay? This is how it looks like. It's this very portion. Now, how do we now derive the formula for calculating the perimeter of a segment? Now, let's redraw this circle in complete what? Order, okay? So let's say this is the center of the circle, okay? From the center of the circle to this very point, I have the what? A radius. Likewise, this other, I also have another what? Radius, right? Then the distance apart is what? Theta. Okay? Then connecting the end of this radius and the other end of this radius together like this, I have my what? Segment. That is this very portion here is my what? Segment. Okay? Now, how do we derive this? From here is our what? Radius. These are what? Radius. Okay? And this is the center of the what? Circle. Okay? Let's call here A and here is what? B. Okay? Now, how do we now derive, how do we determine the length of this word chord? In our previous video, I already explained to us how to determine the length of an arc, which is much easier. Now, I want to derive the length of this chord. How do we derive it? Now, let's divide this chord into two equal halves, okay? From here, divide into two equal halves, okay? By dividing this angle into two, that means each angle on the other side will be theta over what? 2. And the angle on the other side will be theta over what? 2. Okay? Having in that order, you can take it as a what? As a midpoint. Let's turn it towards N. Okay? This is the what? The midpoint. So at this midpoint now, we have that AB is what? The length of this chord, which is the same thing as what? A was N. So the distance from AN plus the distance from NB is equal to what? This was AD. Okay? Because this AN is what? The midpoint of what? A was B. Okay? So invariably, since AN plus NB is equal to A, that means that AN is equal to what? NB. Okay? So this AN is equal to what? N, meaning that if you sum them together, you'll be able to give us the full length of the what? Of the chord. Okay? So invariably, I can as well say that my AB is equal to 2A was N. Okay? Now, let's now proceed to how to derive this word formula. Now, let's take out this section from this word triangle that we are getting into equal halves. Okay, let's take a portion of it like this. So now you see that this is what the midpoint N, and this is the other end, which is what P. Okay, and the upper part here is our angle theta over what 2. Okay, and this is the center point what O. Okay, now our A now here is also our what radius. So you can keep from this point from O to B is our radius. So we want to find a relation that binds this very place and the side that is what given, which is what the radius. So from our trigonometric ratio, we have our SOHCAHTOA. Okay, so from our SOHCAHTOA, now what relationship binds this side, which is NB, and this one OB? Okay, we see that the longer side or the longest side of a given right angle triangle is termed the what hypotenuse. While where the angle is facing as what opposite. Okay, then the other side was here is our adjacent. Here is our what hypotenuse. Why here is our what opposite, because of where the angle was facing. Okay, so by this mnemonic we have here, you can see that what binds the hypotenuse and the opposite here is what? The so. Okay, where this S denotes what? Sine for an angle. Okay, sine. So we have our theta over 2. That will be equal to what? Opposite. And our opposite here is what? NB. Okay. Then our hypotenuse is what? O what? B. Are we together? So from there now we can bring this out to give us that sine theta over 2 is equal to what? NB over what? OB. Okay? So if you have this, we can now go ahead and substitute the value of what? Our OB. We know that our OB is what? It's given as what? This what? Very radius we are seeing, which is R. Okay? So we can have this as sine theta over 2 is equal to what? NB all over what? R. Are we together? So from here, we want to make this what? NB to stand out, to be on its own. Okay, the subject. By indication, you can choose what? To multiply. Okay? You can make that over what? Over 1. Okay? So in that, by this multiplication sign, we will be having 1 times what? NB to be equal to what? R times what? Sine theta over 2. Okay? R sine times sine theta over 2. Okay? Even if we will be having this as what? NB, 1 times NB give us NB to be equal to what? R times sine theta over 2 give us what? R sine theta over what? 2. Okay? So we have found the value of what? This distance NB. And remember I told us that NB is equal to what? AN, right? And the same thing as what? AB is equal to 2 times what? AN. So that means that since NB is equal to what? AN, and those is equal to what? R sine theta over what? 2. And invariably, our AB is equal to what? 2AN, right? Which is equal to 2AN. So we can go ahead and substitute the value of our AN, which is R sine theta over 2 here. So we are going to be having our AB equal to 2 times what? R sine theta over 2. So we are going to be having 2R sine theta over 2. And this is now the word formula for length of this word chord from A to what? B. Okay? So this is our length of chord. Length of what? Chord equal to what? 2R sine theta over 2. Okay? So going back to the derivation of the formula where we say that length of chord plus length of an arc. So I'm going to have that perimeter of this segment will now be equal to what? Length of chord, okay, which is 2R sine theta over 2, okay? Then plus the length of an arc. Remember in our previous video, we already derived how to determine the length of an arc, which we know to be what? Theta over 360 times what? 2 pi what? R. And all this together give us the perimeter of what? Our segment, okay? To use our formula for calculating the perimeter of a word of a segment. So we implore that you follow us and join us so that when next we make our video, which will be involving the calculation aspect of this. We'll be applying this very formula we just derived now in calculating the perimeter of the segment. We won't be left out, okay? So thank you so much for joining today. We hope to see you in our next video. Take care.